Good day, 10Cs. Welcome back to the world of polynomials. So, last lesson we talked quickly about working with monomials. 2xy squared times 3x squared y, and how we multiply those. Multiply coefficients and add exponents that have like bases. So, if, though, we added a monomial times a multi-termed polynomial, well, we just have to make sure we distribute. So then after doing the initial monomial times monomial, we would do the second one. Multiply coefficients, add exponents with like bases. So that was multiplying monomials by multi-term polynomials. Well, today we're going to go multi-term polynomials times multi-term polynomials. So let's take a look at page 17 of the booklet. As I've said a lot with this, I'm not worried about algebra tile work. However, I want to show you how an area model works. So with an area model, we have here x times x plus 6, monomial times a binomial. Well, if you have an area model, this grid, I can put each factor, first factor being x, along one axis here, and then we put the x plus 6 as the individual terms along the other axis. Well, what we're going to do then is we're just going to multiply these parts. X times x. Well, if I do an x1 times an x1, I get x squared. And the second square is then multiplying x times the 6. And x times 6 gives us a 6x. So if I put these two pieces together with this area model, we end up with x squared plus 6x. Well, if I take a look, we already know how to do this. Paper pencil method, x times x is x squared, x times 6 is a positive 6x, and we get this binomial. Doesn't matter which process we use, we get the same answer. Well, what happens, really quick, try this one, make sure we understand the area models. 2x times 2x minus 5. Well, if I want to use the area model, there's my 2x, and it's being multiplied by 2x and a negative 5. Those are the two terms in that binomial. Well, the area model tells us to do 2x times 2x. 2 times 2, multiply my coefficients. X times x is an x squared. And then I want to take my 2x times 1 and multiply it by negative 5. That leaves me with a negative 10x. 2 times negative 5, negative 10. X times nothing leaves us with an x. So we end up with 4x squared minus 10x with the area model. Well, paper pencil method, distribute the 2x. 2x times 2x is 4x squared. 2x times negative 5 is a negative 10x. Same answer either way. So this is just to show you how the area model works, because we're going to use the area model when we take a big jump. Now, instead of distributing a mono times a polynomial, we have two-term binomial times a two-term binomial. Well, this is a little different. Haven't seen this before. Let's take a look at the area model. However, this area model doesn't work because I have x and a positive 5. So what we really need is a bigger area model. The two parts of the first factor are x and a 5. The two terms in our second factor are x and negative 1. So that's what we're multiplying. x plus 5 times x minus 1. Well, when we have all these parts, we see that we actually have 4 multiplications that need to be done. It's not just 2, it's actually 4 of them. So let's fill it in. X times x gives us an x squared. X times our x here times a negative 1 is a negative 1x. Here we have 5 times x for this square, and so that leaves us with a 5x, and this square will be 5 times negative 1, which is a negative 5. So when we have a binomial times a binomial, we end up with 4 parts that we multiply. So what's our answer? Well, we have the x squared, we have a negative 1x, we have a positive 5x, and we have a negative 5. Binomial times a binomial is 4 terms, but look at this, we have 2 like x terms, so we finish with x squared, negative 1 and positive 5 is positive 4x's minus 5. And we end up with a trinomial, 4 terms. So x plus 5 and x minus 1 finishes with 4 terms. The question is, where do those 4 terms come from? Well, what did we multiply first? The first thing we multiplied was x times x. So there was x times x. The next thing we multiplied was x times negative 1. X times negative 1. So this x in this term distributed to each term in the second one. Then what did we multiply? Well, then we multiplied the 5 by x to get our 5x. Well, we multiply 5 times x. And then we multiplied 5 times negative 1, which gave us the negative 5. 5 times negative 1. So there's the 4 multiplications. The x distributed to each term, and then the 5 distributed to each term. And there's how we get those 5 terms. X times x is x squared. X times negative 1 is a negative 1x. 5 times x is a 5x. And 5 times negative 1 is a negative 5, which simplifies when we combine our like terms to x squared. Negative 1 and 5 is 4x with the negative 5. We get this same answer whether we use the area model. We can see those same steps come from the paper pencil model. Let's take a look at another one. Again, another trinomial. 2x minus 5 times x plus 7. So we have a 2x and a negative 5 in our first binomial, and we have an x and a 7 in our second binomial. Well, let's do the 2 together at the same time. We have 2x multiplied by x to fill in this box here. 2x times x, if it helps, put the 1 out front, multiply coefficients, add exponents. So we did 2x times 1x, which is a 2x squared. The next thing we did is we can do 2x 1 times 7 to fill in this box. Well, 2x times 7 leaves us with 14x. So we want that 2x, and we want to multiply it by 7 to get 14x. Now we have our negative 5. And that negative 5 is going to multiply by 1x to fill in this box. Negative 5 times 1x is a negative 5x. Take a look at the paper pencil. Negative 5 times 1x is a negative 5x. And we finish by taking negative 5 times 7 to fill in our last box, negative 35. Negative 5 times 7 is negative 35. All these four parts, 2x squared plus 14x minus 5x minus 35. We need to distribute each term by each term in the second binomial. We're distributing because it's a binomial multiplied, bracket beside bracket means multiply a binomial. And it's 4 multiplication steps. Always look to see if you can combine any like terms. 2x squared, 14 and negative 5 is positive 9x's minus 35. And there's our answer. So this is binomial times binomial multiplication. Now I don't want to use one of those grids every time. So we need a process, and the process is referred to as FOIL. FOIL is what we use for binomials times binomials. Well, what did we do? We had to take our first term because it's a binomial times. Bracket beside a bracket is multiplication. Binomial times binomial. First terms, this is what we multiplied previously, the x times the x. The first terms from each binomial. Then we multiplied x by 1. That x has to distribute to 2 terms. Well, these, if we look, are the outside terms in these binomials. So the O is the outer terms in the binomials. Well, after that, we then multiplied by this 1, and we distributed the 1 times x. Well, these are the 2 inside terms. So we have the inner terms that have to be multiplied. And then we had to finish by multiplying the 1 by the 1. Well, these are the last terms in each binomial. So these are the 4 steps for binomial times binomial. First terms, outer terms, inner terms, and last terms. First terms, outer terms, inner terms, and last terms. The other thing is the term has to distribute to each term in the other polynomial. The term has to distribute by each term in the other polynomial. So if we take a look at that, first, outer, inner, last, first terms. X has to multiply by both terms. X times x is x squared. X times 1 is 1x. Then the second term in that binomial has to multiply. The inner terms. 1 times x is a 1x. And the last terms. 1 times 1 is a positive 1. So we multiplied first terms. We multiplied outer terms. We multiplied inner terms. And we multiplied the last terms. Always look to combine like terms. X squared plus 2x plus 1. And there's your binomial times a binomial. First, outer, inner, last. Give this one a try. Give it a try on your own. Pause the machine, and then we'll do it together. So again, it's a binomial times a binomial because bracket beside a bracket means multiply. I'll show you in a second why that becomes important. But first terms, this 5x has to multiply by both terms in the second binomial. There's my first and my outer step. First, 5x times a 1x, 5x squared because we add those exponents. Outer terms, 5x times negative 3, watch your signs, is a negative 15x. Now we have the inner and the last terms to multiply, which is to multiply now the 2. The second term in our binomial, has to multiply by both terms in the other. So our inner terms, 2 times x, is a 2x. Our last terms in each binomial, 2 times -3, which is a -6. Always, after your multiplying is done, look for like terms. 5x squared minus 13x minus 6. There's the product of 5x plus 2 times x minus 3. Now, very quickly, just to add on to this, what you have to be careful of is a question that looks like this. Because in a question that looks like this, we're not doing a binomial times a binomial because it would be an addition. This is a binomial plus a binomial. In a case where we have a binomial plus a binomial, well, what do? We're not doing FOIL because it's addition of these two. I need to get rid of brackets. What would I multiply this bracket by? A 1. And I would distribute 5x plus 2. An addition sign, we're not bracket beside brackets, it's addition. So what would I do to get rid of this bracket? I distribute a 1 plus x minus 3. So very different answers because I have to combine my like terms here. And this 6x minus 1 is very different than our 5x squared minus 13x minus 6. Pay attention. Are the brackets beside each other, which are telling us to do FOIL, or is there an addition sign between brackets that's telling us to distribute and then combine like terms? You just have to be aware of the different situations. Now we have y plus 6 squared. Now let's look at a couple of goofy ones. This question is starred in the booklet for a reason. Oy, 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 a teacher's nightmare because so many people go, oh, well, y squared is y squared. 6 squared is 36. And so many people want to do that as a shortcut. Wrong, wrong, wrong. The reason being, the question is y plus 6 squared. Well, what does this exponent 2 tell us to do? It tells us to multiply the y plus 6 times itself. You can't just shortcut and square each term because it's 2-term binomial times 2-term binomial. It requires FOIL. Anytime you have a binomial being squared, write it out as the binomial times itself and do the FOIL steps. First terms, y times y is y squared. Outer terms, y plus 6 is 6y. Inner terms, 6 times y is 6y. And the last terms, 6 plus 6 is 36. Combine your like terms, and we end up with y squared plus 12y plus 36. We have part of the y squared plus 36, but that's not acceptable. Make sure you're doing FOIL because it's a binomial times itself. So be aware of those questions. Then we have a question where we have more than just a binomial times a binomial. We do have a binomial times a binomial, but times a monomial. Well, what we have to consider in this case, if I said 2 times 3 times 4, how would you calculate 2 times 3 times 4? Different ways. One possibility would go 2 times 3 is 6, and then you multiply by 4, and you get 24. Another possibility would be I could multiply the 3 and the 4, and I would have 2 times 12, which is 24. What you don't have in this situation is we don't multiply the 2 twice. We would do that if it was 2 bracket 3 plus 4. We could distribute the 2. This is not right. How do we multiply 3 factors? Multiply 2 and then multiply the third. Or multiply the second 2 and then multiply the third. Same thing with polynomials. You want to multiply 2 of the terms. Personally, I see that I have a binomial times a binomial here, so I like to do FOIL first. So I need to do the FOIL process for that binomial. X times x is x squared. X times negative 3 is negative 3x. Negative 4 times x is a negative 4x. And negative 4 times negative 3 is a positive 12. So x squared minus 3x minus 4x plus 12. But don't forget we have this 2 out front. That still has to multiply. I multiplied the first 2 factors, but now I have this other factor that needs to be multiplied, and it needs to distribute by every term, because this 2 needs to multiply by everything. So we get 2x squared minus 6x minus 8x plus 24. Combine your like terms. 2x squared minus 14x plus 24. There's your final product. Multiply 2 of the factors and then multiply the third. Another way to approach this, I could multiply the first 2 factors. 2 times x minus 4. That would be distributive. 1 term times 2 terms. 2x minus 8. But I would then need to take that product and multiply it by the last factor. Well, I don't want to just multiply 8 by it. I need to make sure that this goes into brackets because I want all of 2x minus 8 to multiply by that last term. And again, binomial times a binomial would be FOIL steps. So I can multiply the first 2, distribute, and now do the FOIL process. 2x squared minus 6x minus 8x plus 24. Combine your like terms. 2x squared minus 14x plus 24. Same answer. Doesn't matter which things get multiplied first. But you have to look to do FOIL when it's binomial times a binomial. So, practical applications, we've done some work with areas and perimeters. We can do the same thing for areas. Here we have a square. We see that all the sides are x plus 3. How do you find the area of a square? Well, side times side. This would be x plus 3 times x plus 3. But we want all of the x plus 3 times x plus 3. There's your side times side. Nothing changes, but instead of having a nice, maybe if it would be so much nicer if it was a 4 by 4, well, 4 times 4 is 16. But here, x plus 3 times x plus 3. I can get an expression for the product, binomial times binomial. I'm not going to get a nice simplified answer, nice simple 16, because it's polynomial terms. Combine your like terms, and the area is x squared plus 6x plus 9. Doesn't change. Still, we're finding areas. Here, find the area of a rectangle, length times width. Here's your length, here's your width. So to get area, length, x plus 6 times the width, x plus 3. Binomial times a binomial, make sure you do FOIL. X squared plus 3x plus 6x plus 18. Combine your like terms. Always look for that to finish. And there you have the area of that rectangle. Areas can be calculated with polynomial expressions. Is it realistic? Nah, probably not. But it's a way to incorporate math concepts to get you thinking. So what about a triangle? Well, this really isn't any different than what we have been doing, because how do we get the area of a triangle? We've worked with that. Base times height divided by 2. So, base times height, there's our base, there's our height. Base, 4x minus 2, binomial, times the height, x plus 2 binomial. And all of that is going to have to divide by 2. Well, the first thing you're going to have to do is the FOIL up top. Binomial times a binomial. Again, FOIL steps. 4x squared plus 8x minus 2x minus 4. And all of that needs to divide by 2. Remember, when we're dividing a polynomial by a monomial, every term needs to divide by the 2. So we're going to get left with 2x squared plus 4x minus 1x minus 2, but always look to combine your like terms. The area of this triangle is 2x squared plus 3x minus 2. And there is how we can do polynomial multiplication working with areas of shapes. So we still have more to this video because we're going to go to bigger questions, but to start with right now, if you want to practice that, just binomials times binomials, there's your assignment. Go practice, but come back because we're going to add to this. Or keep plugging away and know that that's part of your assignment. When we go to polys times polys, it's still the same kind of process. It's just questions get bigger and uglier. We're not going to introduce any more math, just more of it. So we no longer have a binomial times a binomial. Now we have a binomial times a trinomial. Well, it's the same kind of process, but FOIL is only 4 multiplication steps. Well, a binomial times a trinomial is more than just 4. So FOIL isn't really what works here. I kind of refer to it sometimes as extended FOIL. This 2x has to multiply by every term in the other polynomial. So instead of just multiplying it by 2 terms as if it was a binomial times a binomial, we have to make sure that it does multiply by all 3 terms. And then this -1 also has to multiply by every term in the other polynomial. So FOIL, first, outer, inner, last, binomial times a tri, same process, but now we have 6 multiplication steps. It's not complicated. There's just a ton going on. So 2x to the 1 times a 1x squared, 2x cubed, 2x times 2x, positive 4x squared. 2x times 1 is 2x. Now I have to multiply everything by the -1. -1 times x squared is a -1x squared. -1 times 2x is a -2x. -1 times 1 is -1. Combine your like terms. 4x squared, -1x squared. 2x, -2x. Leaves us with 2x cubed. 4x squared and a -1x squared is 3x squared. 2x and -2x, well, those cancel out, and a -1. So we still end up with a trinomial in this particular case. Same process, just more steps. Give this one a try. X plus 3 times x squared minus 3x minus 2. Give it a whirl, stop it, and then we'll try it together. So again, binomial times a trinomial. In this case, again, 6 multiplication steps. Because this first term x has to multiply by everything. Because brackets are beside each other, it's multiplication. This 3 has to multiply by every term in the other factor. So here we go. X times x squared is an x cubed. X times negative 3x. Negative 3x squared. Add those exponents. X times negative 2 is a negative 2x. 3 times x squared is 3x squared. 3 times negative 3x, negative 9x. 3 times negative 2, negative 6. So at that point, what are we looking at? X cubed, negative 3x squared and 3x squared. Well, again, those happen to cancel each other out. You're not always going to cancel out, but in this case we have. Negative 2x and negative 9x, negative 11x, and we still have subtract 6. There's the product of that binomial times the trinomial. Lots of multiplication. I'm not going to do this. You can check it. Add-on question. Give it a try if you want. Well, here we go. What the difference here is we have a trinomial times a trinomial. How many multiplication steps? That's the first question. Know what you're multiplying. A trinomial in brackets times another trinomial in brackets. So it is multiplication. Well, how many multiplication steps do you think there'll be? 4x squared has to multiply 3 times. Negative 2x has to multiply 3 times. 6 has to multiply 3 times. A trinomial times a trinomial is 9 multiplication steps. Are they complicated? No. Are there lots of them? Absolutely. So here we go. 28x to the 4. Negative 4x cubed because it's an x1. 20x squared. Negative 2x times 7x squared. Negative 14x cubed. Negative 2x and a negative x is a positive 2x squared. Negative 2x and 5 is negative 10x. 6 times 7 is a 42x squared. 6 times negative x is a negative 6x. And 6 times 5 is a 30. 9 multiplication steps. So we have 28x to the 4. Negative 4x cubed. Negative 14x cubed. Leaves me with negative 18x cubes. 20x squared. 2x squared. 42x squared. 20 and 2 is 22. 22 and 42 is 64x squareds. And then we're left with 10x, negative 10x, negative 6x, negative 16x, and a 30. Trinomial times a trinomial in this case leaves us with a 4-term polynomial. Lots of steps, not any more complicated. Now here is where you have to think a little bit. We have 2-step simplifying. 2-step simplifying because we have 2 polynomials beside each other, brackets beside each other. Well, this is a binomial times a binomial, but then we have addition. This addition sign says stop multiplying. So we have FOIL calculation here. Then this addition sign tells us to stop, and we have another binomial times binomial. And a binomial times a binomial tells us we have a second set of FOIL. So these addition signs or subtraction signs between brackets tell you, hey, stop multiplying. So we're going to do FOIL here, stop it, and then we're going to do FOIL here, but we're going to have to finish by combining all this. So first set of FOIL, 6x squared plus 3x minus 4x minus 2 plus, now we have the FOIL here, Make sure you understand what you're multiplying. X times x is an x squared plus 3x minus 2x minus 6. Combine all your terms now. 6x squared, 1x squared, 7x squared. 3x, negative 4x, 3x, negative 2x. All of the x's can go together. 3 and negative 4 is negative 1. Negative 1 plus 3 is, negative 1 plus 3 is 2. 2 and a negative 2x. All the x's give us 0x. They cancel each other out. So then we're just left with negative 2 and negative 6. So in this case, this whole big question simplifies down to 7x squared minus 8. 2 steps. Because you need to do the multiplying first and the combining second. Because there's 2 separate sets of multiplying. This next one, very similar, but we have to be careful because it's subtraction. Now, if I go back for a second, when we're adding, addition's nice because it doesn't affect signs at all. Technically, we're adding this 4-term polynomial. But an addition sign, really, what are we doing? We're multiplying by positive 1, which didn't do anything. But here we have to be careful because we want to subtract. So again, we have binomial times a binomial. Stop multiplying because we're going to subtract. And then another binomial times binomial. So here we go. Binomial times binomial number 1. 2y squared plus 8y minus 1y minus 4. Now we're going to subtract. And we're going to do FOIL again because we have a second binomial times binomial. Y times y, don't forget, is a y squared, plus 3y minus 2y minus 6. But we have to be careful with subtraction. We don't want to just subtract y squared. We want to subtract everything in that second multiplication. Because a subtraction sign needs to distribute to every term because a subtraction sign changes signs. It's like I'm multiplying everything by negative 1. So we still have 2y squared plus 8y minus 1y minus 4 minus y squared minus 3y plus 2y. Because negative 1 times negative 2 is a positive 2y, and negative 1 times negative 6 is a positive 6. Watch your signs when distributing the negative. Combine like terms. Here we go. 2y and negative 1y squared is a y squared. 8y, negative 1y is 7y. Minus 3 is 4. Plus 2 is 6y. And negative 4 with the positive 6 is a positive 2. And there's your simplified form. So questions get big and questions get a little ugly. So this last one, what do we have to be careful of here? We want to make sure we write this out as x minus 2 times x minus 2. Don't just shortcut it and say, oh, x squared, negative 2 is positive 4. That's not correct. We need the FOIL steps because it's x minus 2 times x minus 2 plus 2x minus 1 times x plus 4. So we have FOIL here, we have FOIL here. And here's the answer. We're adding. So again, because it's addition, it's not going to change anything. I don't need to put all this in brackets at this point because an addition sign is just going to leave it the same. Subtraction sign would change it. FOIL here, 2x squared plus 8x minus 1x minus 4. Combine like terms. We have all kinds of x's. We have -2 and -2 is a -4, plus 8 is a 4, minus 1 is 3x, and then 4 and -4 is a 0, so we don't need it. So there's our answer for that one. Lots going on. There's the second part of this assignment. This is not difficult math. It's just a matter of staying organized. You need to do nice, neat, orderly work. Stay organized. And please watch your boneheads. We don't want boneheads. So please say no to boneheads. Have fun, folks. Get the assignment done. Get the practice. 2 assignments, binomials, and polys times polys.